Okay, good morning, grade nines. How you doing? Mr. Smith here. So this will be a series of videos on helping you with your week 5 homework. We're on the last section of your solving equations unit. And so these are the most, shall we say, complex equations you're going to do. There's a lot of meat on these bones. It's an expression my grandfather would use. So anyways, I just thought I'd randomly pick. I've sorted all of the I printed out the page and I know which questions are for homework, which are for which ones are on a quiz, and which ones I'm having you submit from your homework. So I'll just pick and choose, and hopefully the questions I pick will help you. Okay, let's get into it. Question 6D. All right, so here you've got variables on the both sides. You've got a G here. I'm just going to switch colors now. So you've got a G here. Okay, and you've got a G there. Okay, this one's a negative G. This one has a coefficient of 2.5. The bottom line at some point is you still need to isolate the variable. Okay, so I'm just starring this. All right, that's the goal of algebra, is to get the variable by itself. So let's say on equality you have yada 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 G yada yada, and and then you have yada 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 G and yada yada yada. The point is, this G needs to move over here, or if you so desire, and it doesn't matter, this G needs to go over there. In other words, you must get all your variables on the same side. Okay, and it doesn't matter if it's left or right. Truly, it doesn't. But you have to make a decision about where are the G's going. Okay, so I just thought I'd point that out. I'm just going to pause for a sec while I actually erase this. Just hang on. Okay, I'm back. So let's get into it. We've got negative G here. Sorry, that was... Okay, let's try that again, Mr. Smith. We got negative G here. E is equal to 2.5. So guess what? What did I just do there, grade nines? What did I do? Yeah, I immediately converted my mixed into improper. Okay? Improper. That's supposed to be an equal sign. All right. So, yeah. So it's not 2.5. I'm going to treat it as 5/2. The improper form is much more easy to work with, in my opinion. So you've got 5G over 3. Yes, I chose to rewrite that. Minus 3. Okay. Look, you already have a constant over here. That seems to suggest to me, because if I move the constant to this side, I'm still going to have to then move the G to this side. So that seems like a lot of steps. Seeing as how I have a constant over here, why not just take this 5/3 G and move it over there? Okay? So this is a positive 5/3. So what am I going to do to both sides? Well, why not subtract? Why not just do the opposite? This is the same as a positive 5/3. Why don't we subtract a negative 5 over 3 G? Okay? And whatever you do to one side, you do to the other. Now, before I do this, I just want to talk about something here, and I'm going to circle this in blue, all right? Now, I just want you to redefine what this looks like. So negative G is equal to negative 1G, okay? Negative G is equal to negative 1G. Now, just think, how can a negative 1 be redefined? I could write it just like 1. Remember just the plain old positive 1. Is that not the same as, and I'm just picking random numbers here, is this not the same as, let's say, 10 over 10? Could it be 13 over 13? Could it be equal to 5 over 5? Okay, so look at negative 1 could be equal to negative 3 over 3. I just want you to take note of that, okay? Let's get back to the problem and let's see what happens here. Because I am anticipating something, all right? What do we have here? Well, we've got a 0 pair there, and what are we left with? What are we left with on the right side? It's a negative 3. Now, on the right side, well, nothing changed about this negative G that I started with, and now I'm subtracting negative 5g over 3. Okay? Now, this is negative 1, right? The coefficient's understood to be a negative 1. Negative g is the same as negative 1g. Negative g is equal to negative 1g, and negative 1 is equal to, I just thought I'd repeat that, negative 3 over 3. In other words, another way of saying negative 1, isn't that the same as negative 3 over 3? And I mention that because don't we need a lowest common denominator? So if this is g over 1, why not multiply both of these by 3 to get our common denominator, okay? So we end up with negative 3g over 3 minus 5g over 3 is equal to negative 3, all right? I'm just going to create some space up here. Okay, so you like? I'm really in a color mood today. I'm switching colors. So we have negative. What we have here, grade 9s, is negative 3g minus 5g all over a common denominator of negative 3. Okay. So what you have is negative 8g over 3 is equal to negative 3. Now, there's lots of ways to approach this, okay? You could cross multiply, which is something I like doing. So I'm going to go ahead and cross multiply. Positive 1 times a negative 8g is just negative 8g. That's a g. And we have 3 times a negative 3. Negative 8g is equal to negative 9. Divide both sides by negative 8. Okay, guys, when we get to one step, I'm crossing my fingers that one-step equations are fairly straightforward at this point to deal with. And a negative divided by negative is a positive, so you have 9 over 8, or 1 1/8. And for you guys that are obsessed about decimals, you have 1.125. Okay? So again, we had to make a decision, right? You always have to get your variables on one side of the equation. And this, in this particular instance, I chose to get the variables over to the left side. Doesn't matter, all right? It's just a matter of time and experience will tell you what's going to save you the most steps. You have to just practice the questions. You just have to do these questions. Okay, so I'll pause it here, and I'll come back with something from question 7. All right? See you in a few.